Hello and welcome to this project on vehicle detection and counting. So in this project, we will be working on detecting and counting the number of vehicles in a given image or a video. We will be using OpenCV for image processing and a new thing, HAR Cascade, which is used for object detection. HAR Cascade can be customized. You can create your own HAR Cascade classifier. Currently, there are many HAR Cascade that you can download online for object detection, different body parts detection. So the steps we require to solve this problem statement, this project. So first we will load the image from the internet using the request library. Then we will resize the image and convert it into a NumPy array. Next we will do is we will convert that image into a grayscale because grayscale images are less complex. So we will convert it into a grayscale image. Next we will use the HAR Cascade which we will download from the internet. Already defined HAR Cascade for vehicle classification. We load the XML file which contains the HAR Cascade. We will use this HAR Cascade to detect the vehicle in the image. As soon as we detect the vehicle in the image, we will use the contours to create a rectangle around that detected vehicle. In this case, that is a car. Similarly, we will perform all these operations for another image. That is, we'll do it for bus detection also. For bus detection, we'll download the bus detection HAR Cascade, which is an XML file. Next, we'll also perform similar operations on a video also. And the video will be saved in the end in which object will be detected in particular frames. So as HAR Cascade is used for object detection, we have a very vast scope for this project. It can be used for any type of object detection. We can also create our own custom HAR Cascade for specific objects. With this kind of identification and localization, object detection can be used to count objects in a scene and determine and track their precise locations, all while accurately labeling them. So let's move forward and start building this project. So for this project, we will be using Google Colab as Google Colab provides high computational power and OpenCV requires that. So as we know that in this project, we will be working on detecting and counting the number of vehicles in a given image or a video. We will be using OpenCV for image processing and HAR Cascade, which is used for object detection. And I already told you that you can also create your own customized HAR Cascade classifiers. In this project, we will be using the cars.xml HAR Cascade and busfront.xml Cascade. So you need to download that from the internet and we will store it in our Google Colab here in the file section. I've already uploaded the busfront.xml and the cars.xml file. So I'll also show you how to detect object or a vehicle in a video. So I have uploaded a cars.mp4 video also here. You can select any video that you want, but it should contain some vehicle. So let's start this project. So we'll start by importing some required libraries, such as we will import image from PIL, which will be used for loading the image or visualizing the image. We will import CV2. So CV2 is OpenCV used for computer vision and image processing. We'll import NumPy. NumPy is used for mathematical computation. And we will also import request. So request is used to fetch the URLs that pass to it and download the data from that URL. So let's run this cell and import these libraries. So as our libraries have been imported, the first thing we should do is we should download our image that we will be working on. So first I'll show you how to detect an object that is a vehicle, car, from an image. So I have taken an image from image URL from internet. You can take any URL, any image. It should contain some cars because we're working on vehicle detection. So it should have some car in that image. Here you can see that I have used request function. So this request function will fetch this URL and this image will be stored using image.open. Similarly, I am also resizing this image and converting it into a NumPy array. So let's run this cell and visualize the image that we'll be working on. So here you can see that this is the image that we will work on. In this image you can see that there are many cars and we will work on identifying them and counting the vehicles. So next what we'll do is, in order to get a better output, we will have to perform some transformations on the image that we are using. And the first transformation here we are doing is, we are converting the image into a grayscale. Let's run this cell and perform this operation. So here you can see that our image has been converted into a grayscale. Now next what we'll do is, we'll apply the Gaussian blur. So what Gaussian blur does is, Gaussian blur removes the noise from the image. So instead of a box filter consisting of equal filter coefficients, a Gaussian kernel is used. And it is performed using the Gaussian blur function of CV2. We just need to specify the height of the kernel, which should be positive and odd. So let's run this. So here you can see that blur is applied to the image. So now next we will see how to dilate an image. So here we will dilate the image using the dilate function. It is just the opposite of the erosion function. So here a pixel element is 1. If at least one pixel under the kernel is 1, so it increases the white region in the image, or the size of foreground object increases. Let's run this cell and dilate our image. So here our image is being dilated. All these operations, all these transformations are necessary because in order to get a correct output, we should perform all these operations to make an accurate output. Now next step will be performing the morphological transformations with kernel. So we are using the morphology X, which is used to find the difference between the dilation and the erosion of an image. We may need elliptical circular shaped kernels. So for this purpose we are using the OpenCV function get structuring elements, and we just need to pass the shape and size of the kernel and we get the desired kernel. So let's run this cell and perform the morphological operations. So here you can see that morphology has been applied to our image. Let's move forward. So next what we'll do is, we will need a car cascade to detect the cars. And as I have already showed you, the cars.xml file, I have downloaded it from the internet. It is a HAR cascade file for car detection, and I have stored it in the file section here as I showed you before. So we'll load that car.xml file, and what we'll do is, we'll create a car cascade using the cascade classifier. Here you can see. So first we need to upload them to the Colab and then specify the paths to the car cascade SRC. Okay. Now OpenCV provides a training method, which is the cascade classifier training, or the pre-trained models, and that can be read using the cascade classifier method, as you can see here, the car cascade SRC file. We need to detect multiple objects, that is car, so we will use the detect multi-scale function of car cascade. Detects object of different sizes in the input image, and the detected objects are returned as a list of rectangles. So let's run this cell and perform this operation. Next, what we will do is, now we will use the above written contours and draw a rectangle around all the detected cars. So here we will see that it will create the rectangle with red boundary around each and every car it detects. So here in the output you can see that it shows us that 22 cars are found. So it has found 22 cars, and you can see that around every car it has found, it's created a red color triangle. Some cars are not detected because it is not 100% accurate, but yeah, most of the cars are detected using this. Now let's move forward. Now we will use another image, that is bus image. You can take any bus image and we will fetch the image from the internet here. Here you can see that I have taken a URL from the internet, and request will fetch this image for me and it will store it in the image.open using image.open into an image2 variable. Similarly, we will resize this image also. So here you can see that I have resized it into a 450 by 250, and also I am converting it into a NumPy array, which will be further converted into a grayscale image, all in one step. So let's run this and see what image we are working on. So next step would be, as we are working with the bus image here, so we require the cascade for detecting the bus. And as I have already told you, I loaded it into my Google Colab with the name busfront.xml. So I am passing the busfront.xml file here. And similarly, as we have used the cascade classifier above, we'll use the cascade classifier and call the bus cascade src function here. And as we are detecting multi-scale, as we are detecting multiple buses, so we are using the detect multi-scale. We'll run this cell and perform these operations as performed above. These are the similar operations as we perform for the image above. After this, as we did in the car cascading, similarly we will perform the same contour operations on the bus image. And here also we will create a rectangle around the bus if detected any. So let's run this cell. And here you can see that it shows us one bus found and created a rectangle in the front of the bus. So next what we'll do is, we'll perform the vehicle detection and counting in a video. So video runs by frame to frame. So for creating the output video from frames or images, we need to use cv2.videowriter method. What it does, it takes a path with extension as first parameter. Second parameter is the codec for the output format. And then we also need to pass the frames per second and height and width also. So here you can see that I have passed the results.avi as my output file. It will use video writer and divx will be the codec for that. And this is the height and width of the video. I've already shown you that I have uploaded a video here in the file section with name cars.mp4, and we are going to use that video. So let's run this cell and perform these operations. So after this, what we'll do is, now we'll read the video frame by frame, the input video, and we'll convert them into a grayscale using the car cascade. And we will detect all the cars in that particular frame. And in the end, what we'll do is, we'll write the whole video using the video.write method, and then we'll save it using the video.release to the given path. Let's run this and convert our video into a grayscale, and using the car cascade to detect the cars in that particular frame, and save that video frame by frame using the video write and video release function. Let's run this cell. It will take some time. It depends on the video, how big or large video you are using. While selecting a video, you should take in consideration that it should contain some images, some cars in it, or any object that you are working on to detect that object. So it will take some time as depend on the size of the video, or as it will convert it into the frame to frame. So it will take some time. So it took around 5 minutes for this step. Now let's move forward. So here you saw that we use this cv2.rectangle for creating the rectangles around the car. We'll detect multi-scale as we are working on multi-scale, and we use the colored image and convert it into a grayscale. And in the end, we saved the video. So with this, we came to the end of this project. So we started with downloading the image that we will be working on and performed some operations on that image. You see how much pre-processing we did on the image that we worked on. Similarly, we saw how we can use HAR cascade, which is used for object detection. We used HAR cascades for car detection and bus detection. Similarly, there are many pre-trained HAR cascades for different object detection. So the scope for this project is that as a HAR cascade is used for object detection, we have a very vast scope, and it can be used for any type of object detection. And as I've already told you, you can also create your own custom HAR cascade for specific objects. Next, I will show you how you can create an application for this, an application for vehicle detection and counting. So let's move forward. So for this vehicle detection app, vehicle detection and counting, we will be creating a Flask app. So in order to create a Flask app, we need to do certain Python scripting. Here you can see that I have created a folder with the vehicle detect count app. In this, I'll explain you all the files that I have created and which are required. So first, let us see the config file, which is the configuration file. In the config file, we have created a class named config and passed an object. We have set a secret key to PyAnalytics. You can change it to anything that you want. And we also set the session cookie secure as true and default theme as none. As we will develop an app, so we are using the class development config, and we have set the debug equal to true. So this is the configuration file. Next, I'll show you the app.py file. So this app.py file, this is the main file. So if main is encountered, whenever main is encountered, the app will start running. And we have imported the app from app. So the next important file is the init.py file. So the init.py file, it is the initializer. It will initialize our app. So in this, we are importing Flask from Flask, and we are passing the Flask to app variable. In this, you can see that we have called the config.development config, which we created in the config.py file. Similarly, we are also importing views from app. So this will import the views.py file. Let us see what is views.py file. So this is the views.py file. So in views.py file, you can see that I have imported some required libraries, which are, we have imported app from app, we have imported request render template and URL for from Flask, we have imported CV2, which is OpenCV, computer vision, imported NumPy, PIL, imported string, random, and OS also. So initially we will config this, and initial file uploads, set the path to app static uploads. After that, we will store both the files here that we will use, the car cascade one and the bus cascade, the XML files, as I have already told you in the project during the collab. So an app runs through two different positions here, that is get and post. So whenever the app started, it will go into get. So get will show us get will be fetched, it will show us the home page of our application. So if request.method equal to get, it will show us the white background and render the template of the index.html, and index.html is our home page. And whenever we click anything or we do something on our home page, it will execute the post command. So in the post command, you can see here that we are using an image upload button, and we will upload an image here. After that, we will generate a unique name to save the image, and this full file name will go into the uploads folder with the name which is generated here. After that, you can see that image will be opened using image function of PIL. We will resize it, we will convert it into a NumPy array, and then we will convert it into grayscale. So all these functions, all these functionalities, these pre-processing, we have already done in Google Colab. These are all the same steps as we have performed there. So as you know that we have performed the cascade classifier, so here you use the cv2.cascade classifier, same as the Colab. Similarly, we are detecting multiple objects, multiple cars, so we are using the detect multiscale. And after that, we created the rectangle. We use these rectangles to form contours, and similarly these contours will form the rectangle around the image. In the end, you can see that we are saving the image using img.save in the app.config initial file uploads path as we have set above, and in the end it will return to the page where we are working. And here you can see that this is the main function, and the main function will call app.run, so our app will run. Next, let me show you the index.html file. So in order to understand the index.html file, you should have a basic understanding of CSS and HTML, as this whole document is created in using CSS and HTML. For creating this, here you can see that I have set the title as vehicle detection count classification app. I have used materialize.css. You can go through the internet and search about materialize.css and learn how it works. I have used it. Here you can see that in the first division, I have set the title as the vehicle detection count classification made by PyAnalytics. Next, you can see that I have given a upload image label, and we can browse the image using this browse button. After uploading the image, the next section is displaying the image or the output. So for that, we have created this class, this division, and in the end we have passed all the scripts that will be required to run this index.html file. As we are using the materialize.css here, and we are also using some buttons like browse, and we are using image upload, so all those functionalities we need to pass them as a script. So here in the end, you can see that I have passed the source for the script like materialize.js, as I am using materialize.js, also JavaScript. So this is our index file. Index file is the front end, how our app will look. This is used to design the front end. Next, let me show you one of the most important file for deployment. So this is the proc file. So proc file, what it does is it tells the machine, the deployment, that it is a web app because we have stated here web, and Gunicon will call the app from app. Similarly, one of the other important files is the requirements.txt file. So a requirement.txt file, you can generate this on your own. What it contains? It contains all the required libraries, on which our project depend. And for creating this, you just need to run a simple command, that is pip reqs. Let me show you how you can do that. So first you need to copy the path of this folder where this whole project is saved and open the Anaconda command prompt. So let me show you how to do that in the Anaconda command prompt. So here in Anaconda command prompt, you first need to move to that particular folder where our project is saved. For that, I have already copied the path. I'll type cd, that is change the directory, and paste the path here. So now I'm in the exact path where my project is saved, and now I'll run the command pip reqs. So what it does, it will create a requirements.txt file. Before that, let me show you how you need to install this pip reqs. So you can install this using pip install pip reqs. So as I have already installed this on my system, it will show me that requirement is already satisfied. But you need to check it on your system if you have installed it or not. After this, we will create the requirement.txt file by running the command pip reqs. Let's run this and see. So what this will does is, it will create a requirement.txt file in my particular folder where I am running this command. So what it does, it will check all the Python scripts there, and it will get back to, it will create a file which will contain all the dependencies, all the libraries that are required. So here you can see that requirements.txt has already exist because I have already created that, and I can override that using the ---- force. So no need to override that because I have already created that, but in your system it will create a new one. So let's see how we can deploy this app. So for deployment, we need to get a GitHub account. So let me show you how to use GitHub and deploy this app. So here you can see that this is my GitHub account. So in my GitHub account, I have created a new repository with the name vehicle detect count app. You can also create a new repository by going to this plus sign and creating a new repository. After creating the new repository, you need to copy the project here. So I have created all the files and then I have imported them to my GitHub account. Here you can see. So as I have already shown you, this is the proc file, the app.py file, config, readme and requirement. Every file is here. So this is my GitHub account. Now in order to deploy this app, we will use Heroku deployment. Heroku deployment is easy and also it is free, as we are not using it for commercial purpose. We are only using it for educational purposes. So let me show you how you can deploy this app on Heroku. Before deployment, you need to complete this step because Heroku will take the project from your GitHub account. And if you don't have the project in your GitHub account, Heroku won't work. So let me show you how Heroku works. So for that, we will go to the dashboard.heroku.com. This is my dashboard for Heroku. In this, you should go to the new and create a new app. So while creating the app, you should name the app, as it is a vehicle classification. So let me vehicle counting. So let me change the name to vehicle detect app. Currently it supports only 2 regions, so we'll select any of the one and create the app. So as soon as you create the app, it will show you the overview or the deploy one. So now you need to deploy this app. You can use Heroku Git, that is Heroku command line interface, and do that manually from your system. But an easy way to do that is you can connect your GitHub directly to your Heroku account. So we'll click on this and connect our GitHub account. So here you can see that it connected to my GitHub account, which is with the name of PyAnalytics 1. Now we need to search the repo, the repository that we are going to deploy here. So we'll search that repo, and here you can see that it is the vehicle detect count app. I'll connect this. So it connects to my vehicle detect count app repository on my PyAnalytics GitHub account. The next step will be choosing a branch. So here you can see that this is the main branch and all the project requirement files are in main branch. So this is correct. This is the main branch. We should also enable automatic deploys, so that if we face any issue while deployment, or if the app is not deployed and we go to the GitHub again and change the code, it will automatically deploy. We don't have to deploy it again and again. So now we will deploy this branch by clicking on deploy branch, and we'll see what are the logs for this. So firstly, it will show you this log. Here you can see that it has detected that this is a Python app. After that, it installed Python and other required libraries, as we have mentioned in our requirements.txt file. All the libraries will be installed. Here you can see after installing all these, you see there Procfile declares type web. So it will know that this is a web application. After this, it will compress our project, and here you can see that our project is compressed to 84.9 MB, and it launches our project. Here you can see that this is the URL for our project. Copy this URL and we'll run it. So here you can see that our app is working. Vehicle detection count classification app. So let me check how it is working. We'll browse to an image. So here you can see that I am loading a car image here and clicking on the process button. So in the output, you can see that it detected 26 cars, and all the cars are inside a rectangle and there are no buses in it. So this is how you create a vehicle detection app and deploy it online. I hope you find this useful. Thank you.